The people who win will be the people who know how to operate systems of intelligence. The second failure mode is context rot. If one session keeps looping forever, the context gets huge. The model starts carrying old decisions, old tool outputs, old failed attempts, and random noise. That is why serious setups use work trees, isolated sessions, state files, logs, and handoffs. You do not want everything trapped inside one giant chat. You want the important state written somewhere the next run can read cleanly. Hi, my name is Jack. Come here for AI agents and workflows. Stay to become a world-class AI operator. If you use Claude Code, Codex, Casa, or any coding agent right now, be honest. You are probably not doing AI automation. You think the agent is working for you. But every few minutes, it comes back and asks, what now? That is why everyone in AI coding is suddenly talking about loop engineering. Peter Steinberg said you should stop prompting agents and start designing loops that prompt them. Boris Shirley from Claude said his job is to write loops. Adi Osmani gave the pattern a name, loop engineering. But I think the internet version is slightly wrong. Prompt engineering is not dead. It got demoted. The new skill is designing the system around the prompt. And this goes beyond harness engineering. You now have to think in terms of what triggers the agent, what context it gets, what tools it can use, how the result gets checked, where state is written, when to repeat, and when to stop. So this is the complete guide. By the end, you'll know what loop engineering actually is, which loops are worth running, which ones quietly turn into token furnaces, and the 3 boring loops I would build first. Here is the core idea. Loop engineering is not really about making agents work forever. It is about deciding which parts of the work loop should happen without you. So let's break down what such a loop might look like. And I want to do it with an example that is super clear and easy to understand. Imagine every morning an agent checks your inbox, open tasks, and project notes. Normally, you would scan the summaries yourself to see what changed, what matters, and what should I do today. A loop turns that into a system. But here is the important part. You do not start by asking for a better prompt. You start by writing the loop contract. That contract is the asset. That is why the free starter kit starts with the readiness checklist and loop contract, not a prompt pack. To get it, click the link below, go to Classroom, click the starter kit, then click the loop contract free template. That's it. The state is the brief it saves. And the stop condition is clear. Stop when the brief is complete or escalate anything risky to you. That is a real loop, not because it is fancy, because it has 7 parts. And once you see it that way, the prompt becomes much less important. The prompt is still there, it still matters, but it is now one part of a bigger system. There are 2 terms people are mixing up right now, slash loop and slash goal. The easiest way to remember it is that slash loop watches, slash goal finishes. Use slash loop when something needs to happen on a cadence. Every 30 minutes, check new GitHub issues and summarize anything urgent. Or every morning, review stale pull reports and tell me what needs attention. That is a watching job. Use slash goal when the agent needs to push towards a finish line. Or keep working until the auth test pass on the doc's drift report is complete and verified. The expensive mistake is putting one on the other one's job. If you use loop for a finish line task, it can keep waking up after the work is already done. If you use goal for something external the agent cannot control, it can spin forever trying to make reality change. So the basic decision table is, if the job requires taste, judgment, money, production rights, or customer communication, keep a human close. If the job is to finish, use a goal. If the job needs to survive after your laptop closes, use a real automation. If the job is to observe, use a loop. Now here is the part most people miss. The loop is not the hard part. The verifier is the hard part. Anyone can write a loop that says, run this prompt every 5 minutes. That is not the skill. The skill is knowing what evidence proves the work is done. Loops win where verification is cheap. If the output can be checked, for example, by tests, lint, types, or even a screenshot, a diff, or a structured report, loops can be very powerful. But if the output can only be checked by asking, does this feel right? Then the loop needs much more supervision. That right side path is not useless, but it is dangerous if you treat it like the left side path. When the model is doing the work and judging whether the work is done, you need more supervision. That is where people get into trouble. This is also why the maker-checker split matters. The agent that writes the code should not be the only agent that grades the code. Never let the model grade its own homework. Have one agent make the thing, have another agent, preferably read-only, check the thing against the contract. And when the stakes are high, the checker should produce evidence for you, not just a vibe. Evidence like I read these files, I ran these commands, these checks passed, these risks remain. This should stop, try again, or escalate. That is the difference between loop engineering and just automating chaos. Loops can also break, and there are 3 big ways that they do so. The first is cost. Loops multiply work. The agent does not just answer once. It plans, acts, checks, retries, spawns workers, reviews output, summarizes state, and maybe does all of that again. Theo talked about loops burning millions of tokens. Cole showed simple orchestrated runs crossing 1,000,000 tokens. That does not mean loops are bad. It means loops are leverage. And leverage cuts both ways. If the loop is pointed at the right thing, you get a lot of work. If it is pointed at the wrong thing, you get a lot of wrong work. The second failure mode is context rot. If one session keeps looping forever, the context gets huge. The model starts carrying old decisions, old tool outputs, old failed attempts, and random noise. That is why serious setups use work trees, isolated sessions, state files, logs, and handoffs. You do not want everything trapped inside one giant chat. You want the important state written somewhere the next run can read cleanly. The third failure mode is false confidence. This is the dangerous one. A bad loop does not always fail loudly. Sometimes it fails politely. It says done, looks good, all set, but nothing actually verified the work. No test, no diff review, no screenshot, no contract, no checker. That is worse than an obvious failure because it feels complete. Bad loops do not fail loudly. They often fail politely. This is where I think most of the conversation is missing the point. The people who win are not going to be the people who collect the most AI tools. The people who win will be the people who know how to operate systems of intelligence. That is why I like the word operator. An operator is not just prompting. An operator is designing the work environment. And in loop engineering so far, the operator stack has 5 layers. Layer 1 is the harness. Make the environment legible and executable. Can the agent understand the RECI? Can it run the app? Can it run the tests? Can it find the rules? Can it work in a separate work tree? Layer 2 is the loop contract. What is the job? What is in scope? What is out of scope? What counts as done? When should it stop? Layer 3 is the state layer. This is the AI JSON point I really like. Loops compound when they share memory, artifacts, signals, tasks, tickets, logs. If every loop writes useful state, the next loop gets smarter. A support loop can create product signals. An SEO loop can create content opportunities. A bug triage loop can create engineering tasks. The power is not one loop. The power is the shared operating system around the loops. Layer 4 is the checker. The maker makes, the checker checks. The checker should be boring, strict, and evidence-driven. Layer 5 is the human checkpoint. You do not remove the human from everything. You remove the human from the repetitive parts. The human stays where judgment matters, like architecture trade-offs, taste, product decisions, risk, permissions, and customer impact. That is the operator stack: harness, contract, state, checker, human checkpoint. And this is why the free starter kit starts with the loop contract. If the contract is vague, every downstream agent will be vague. So what should you actually build first? Not run my company, not refactor my entire code base, not work while I sleep. Start with something boring, because boring loops compound. One example is a docs drift reporter. The agent reads a PR or Git diff, looks for docs that might be stale, and writes a report. Another good one is a stale PR or issue triage. Every morning, the agent opens work and tells you what is blocked, what needs review, what is stale, and what needs a decision. Third option is failing test repair, scope to one folder. This is the first loop I would try that has right permissions. The goal is concrete: make this specific test command pass. The goal is narrowly scoped to one folder. The verifier is obvious: the test passes or it doesn't. That is a real loop, with a small goal, a clear verifier, a tight scope, and an obvious stop condition. After that, there are a few practical loops I would test: a performance loop, a production error sweep, an SEO or geo audit loop, and a product evaluation loop. If you want the practical version of this, I put the loop engineering starter kit inside the new operators. It includes the readiness check clause, the loop contract template, the goal versus loop decision table, the maker checker verifier prompt, and the first 3 loops I would build. The video gives you the model. The kit helps you run your first loop without letting the agent run wild. Join the new operators below and grab it for free. Prompting got us good at talking to AI. Loop engineering is how we stop hand-holding it.